Welcome to class P. Today we are going to discuss about the topic applications of trigonometry. So already we discussed about the trigonometry. So here we are going to discuss about the applications. Applications means real life situations. So it is nothing but real life situation. Means in the trigonometry we are finding the ratios, angles and all those things. But here how can we use the trigonometry in the real life situations? For example, we are finding the distance that is we used in the mensuration. But here also we can measure the heights and the distances and the particular angles between the objects we can discuss here. So heights means we are having the Everest and Kuntala waterfalls, means whenever we are observing the certain distances and some waterfalls or some angles we are discussing. So is it possible without measuring, without the instruments? So here we are going to discuss the such heights and the waterfalls or angles from the observer to the particular objects. That is we are going to discuss. How can we measure? So here we are having some concepts. So with the using of that concepts we can identify the particular distances and angles and the such values. So here I am giving some applications concepts here. We are having the first point, line of sight, and the second point, line of horizontal, and the third point, line of elevation, and the fourth point, here line means we are having angle, and here also we are having angle of depression. So here what is the meaning of line of sight and line of horizontal and angle of elevation and angle of depression? How can we say these four concepts? If we know these four concepts, we can identify, we can measure the angles and the distance of the particular objects. Here we are using always right angle triangle to find the particular distances or objects heights or angles also. So here line of sight, how can we define? Line of horizontal, how can we define? In the right angle triangle we are having, this is the hypotenuse and this is the base of angle, and this is the opposite to the angle or side, we can say one of the side in the right angle triangle. Here angle 90 degrees, this is the particular angle, this is also one of the particular angle. These two angles always should be acute, to be discussed in the trigonometry. But using this type of angles and using this right angle triangle, we can identify the particular distances and the angles of the particular objects. So our topic first one, horizontal line. What is the meaning of horizontal line? A line which is parallel to the base or the ground or the earth, that is called horizontal line. So in the right angle triangle we are having here, this is the ground level we are having. I am taking here ABC. Here AB is the base or earth or ground level, ground, and AC is nothing but hypotenuse, we know, or we can say this is the angle of sight, and BC is nothing but, here we are having opposite side, or we can say the object height. So if we know these concepts, we can identify the horizontal line. So a person standing here to observe a particular object, he is standing here, this is the ground level or earth level, he is standing on the earth, and this is the tree or tower, whatever we are taking the observation, this is the object. He is watching top side, the edge of the particular object, he is watching, but he is watching here particular place, this is called horizontal to the ground. This is the we are having this is the horizontal. This line is called horizontal line. So coming to the next point, line of sight. How can we define? He is standing on the ground level or on the earth. He is watching the particular point of the tree or the object or the tower. Then he is looking this one. This is called the line of sight. This is the line of sight. This is the horizontal line. One more point, line of depression. In the diagram, again I am taking this is the tower or tree, and the person is watching here to watch a particular flower or object. He is standing on the tree or on a house or a tower. He is watching to see the flower. And if we are taking here the level, it is the horizontal, and this is called line of sight. So here we are forming, this is the way we can find the line of depression. Here also we can say we are watching here downwards, it is equal to the angle where we are forming here. We are taking it, one is the theta and it is also theta. For example, if we are taking this one theta 1 and this is the theta 2, here also we are forming one angle, this is theta. So why I am saying about the line of sight and line of depression, and coming to the here angle of depression and angle of elevation. I'm giving here line to parallel of ground. It is the horizontal line. Line of sight, we are having observation of person to a place or a point, we can say, and a depression, angle made by observer. Here also angle means the angle of elevation, angle made by observer. You can take angle of elevation, angle made by observer above the horizontal, and here below the horizontal we are having. So the person is watching from the ground level, the angle made here above the horizontal line, it is called angle of elevation. And here the person is observing, here also we are having the horizontal line here, and this theta 1 is the angle of depression we can take, and here I am taking the theta 1 is equal to theta. Why? Because both thetas or both angles we can consider as equal. Why? Because if we are forming the horizontal line, it is parallel to the ground level, it is the ground or earth. So the line of sight forming here as a transversal, these theta 1 and theta 2 angles are alternative angles. That's why we are taking both the angles are equal. Whenever we are taking the angle of depression or the angle of elevation, both are acute angles only. So here I am giving some important points, so should keep in your mind. How can we take that all situations to form a right angle by the given problem? How can we construct? If we need to construct the particular diagram, then only we can identify the unknown value from the known values from the given conditioner from the problem. The first point, the angle of observer moves towards the perpendicular line. This is nothing but pole or a tree or any object. Then the angle of elevation increases, and if the observer moves away, moves away from the perpendicular line, the angle of elevation decreases. Means we are having the particular diagram like this. This is the object we are taking, and the person is here. He is watching from here onwards. From this point he is watching to the height of the building, and what is the meaning of this point means the angle of observer moves towards to the perpendicular to, means in this manner he is moving to the object part we are watching. The angle should be increases. The angle is increases, means this angle will be increased. Then the observer moves back. If he is moving towards to the particular object, the angle is increasing, and if he is moving back, then the angle should be decreases. This is the meaning of this point. If he will go the particular object, it is increasing, increase. If he will go back from the particular place, then the angle should be decreased, decreases. This is the meaning of this point. And the second point I am giving here, the height of the particular tower or object is doubled, then the distance from the observer and the foot of the tower is also doubled, but angle of elevation is same. So the particular height of the particular object increases, automatically the observer's angle should not be changed. The sight of the observer will be doubled. This is the meaning. And height changes, then the distance also changed, but no change in the angle. Next, third point, if the angle of the sun above the tower decreases, then the length of the shadow of a tower decreases. Means we know very well sun rises and sun sets. At that time the particular objects will be look like in the shadow, increasing or decreasing. So in that case that should be a reverse process. If the height of the tower is increases, the length of the shadow also decreasing. If the height of the tower increases, the length of the shadow will be decreases. So this is the third point we are having. These are the 3 points. Means why I am discussing these, we are having such type of problems. If the shadow is increasing or decreasing, what we will get, and if the person is moving towards to the particular object, and the person is moving back from the particular object. So it is very little bit confusion question in our problematic problems, and we are unable to draw the diagram. So that's why I am giving that 3 points. So we using these concepts we can draw the diagram, then only we can identify the unknown value from the known values. So we know always that theta should be equal for the person watching from the upside of the towers or the houses or the particular areas to watching the downwards objects. So we are taking 2 angles, downwards and upwards, both are equal. Already I discussed that. So we are having solving problem. How can we solve the problems? We need to get the concept from the given question, then we can understand. We should arrange the diagram in a proper manner, then only we can identify the unknown value. For that purpose I am giving some instructions to draw the particular diagram to get the unknown value. This one is to solve a problem we should consider the following rules. So which rules we should follow? All objects such as towers or trees, so on etc., such be considered as linear for mathematical convenience. And the second one, angle of elevation or depression is considered with reference to horizontal line. And the third one, the height of the observer is neglected or if it is not given in the problem. These three conditions we need to get from the problem. By using these conditions, we should draw a diagram, then only we can identify the particular unknown values. So in this topic, I'm going to give some useful tricks to solve such type of problems. So heights or distances or angles, how can we identify? First one, hints I'm giving. First one, draw a neat diagram of right triangle or combination of right triangles. If necessary, I am saying such cases we are having two situations. We need to draw at a time two diagrams. He is watching upwards from the particular place, he is watching downwards. In this case, we are having the combination of right angle triangles. How should we construct? I am saying that point. And the second one, represent the data given on triangles. So means what is the question is there that all objects what we are having the data we should represent on the drawn right angle triangle. Next, third one, find the relation between known values and unknown values. Then the fourth point, choose appropriate trigonometric ratios and solve it for unknown values. Trigonometric ratios I said. So here always in the chapter maximum cases we are using the three ratios, sin theta and cos theta and tan theta. These are the main trigonometric ratios we are using to find the angle or to find the particular distances from the particular objects to the person or person to the objects. We are using these hints, we are drawing the diagram, then only we identify the unknown value from the known value. So how to draw diagrams I am showing, just examples I am giving. So to draw a figure to solve problems, how should we draw the diagrams to get the answer? So I am giving one example here. This is the ground level. Here we are having the tower. This is a tower I am taking, and we are calculating tower height here from here to the ground level as h I am taking, and a person is watching here from the ground level to the top place of the tower. He is watching the top point. Okay, and his horizontal line is like this, we can arrange, and he is forming an angle theta. So in this manner we can draw, means he is watching the top point of the tower from the ground level, and he is standing perpendicular to the ground level. Then we are taking this one as horizontal. This is the horizontal, this is the line of sight, and this is the angle of elevation. So in this manner we are drawing. And second example I am giving here. I am taking one more here, one building or tower. We are taking a person is standing here, and he is watching one plant or tree. How he is watching, and we are taking, this is the horizontal, and he is forming angle here theta 1, and we are taking, this is the height we are having here, and we are taking this one, he is watching, and here we are having one more theta 2 we are taking. And how can we define this one? As here this is the horizontal, and this is the line of sight, and this is the angle of depression. So here theta 1 is equal to theta, already I discussed, and two situations are drawn here. So already I discussed, draw a neat diagram for the right angle triangle, combination of the right angle triangle also. So the person is standing on the ground level, he is watching topmost of the tower. We will get the diagram like this. The person is watching from the towers or the trees or the particular houses and watching downwards of that particular area. In this manner we are drawing. If the third situation we are having here, I am taking here, the person is standing on the house. This is the house. What he is watching, it's a balloon I am taking here, and he is standing there, and he is watching top of the balloon, and at the same time he is watching the point where the thread tagged. So here we are taking, this is the horizontal line for the both diagrams. He is watching upwards, this is the theta 1, and he is watching downwards, this is the theta 2, and we are taking this one as theta 3, and this is the particular height we are having the particular balloon. So here we are forming at a time two angles, angle of elevation, angle of depression. In this manner we can arrange the diagrams to get the answer.